Hello, and welcome to our channel, where we explore everything. In this video, I'll be sharing my experiment on creating an AI chatbot with a streaming feature in Odoo 18. If you're a beginner, you might be wondering, what is this streaming feature all about? Simply put, it enables users to receive chat responses as they're being generated, rather than waiting for the full response to be generated. This results in a much faster perceived response time, especially when dealing with long responses. Let's take a look at an example of how this works. As you can see just now, the streaming feature greatly improves the perceived response time. Unfortunately, implementing this feature using the Discuss app is not an easy task. However, if all you need to do is chat with an AI without any advanced features, there's a much easier way to implement it. We'll be exploring that alternative method in this video. In our experiment, we're going to use several additional components: LM Studio for the AI platform with Llama 3.1-8b, Instruct for the AI model, Semantic Kernel for our AI framework, and NLUX for the chat UI. You can find links to these components in the video description below. To get started, we need to create a new module from scratch. This involves creating a manifest file, initial init files, and setting up the directory structure. On the server side, we'll be creating a new controller to handle chat requests from the client side. The controller will then pass these requests on to an AI bot instance. The AI bot is a simple class that uses Semantic Kernel to communicate with LM Studio. When an instance of AI bot is created, it automatically creates a Semantic Kernel agent using the basic setup. For more information about setting up Semantic Kernel, please visit their official documentation. Next, we'll be creating a utility method to use semantic kernel functions. This is necessary because semantic kernel agents return asynchronous results. Depending on how the chat is requested, we'll either run the stream chat method for streaming responses or the chat method for regular responses. For regular responses, we simply call the invoke method of the agent and return the first item in the iterable returned by that method. For streaming responses, we use the invoke stream method to request streaming responses from LM Studio, which are then sent to the client using our send stream to client method. This method is crucial for streaming chat responses. When sending these response parts, we need to create a new environment instance for each part, otherwise they'll only be sent at the end of the process. Let's compare this with an example of how it would work without creating a new environment instance. With a new environment instance, we send the response parts with the bus send method of the current user with our own notification type, AI bot stream. This notification type will then be used in the client side. Now that the server side is set up, let's move on to the client side. If you plan to host the NLUX library yourself, you'll need to download it first. Unfortunately, their GitHub repository doesn't provide transpiled JavaScript files. To work around this, we can use online repositories such as npmjs.com, yarnpackage.com, or CDN providers such as jsdeliver.com. For this experiment, you need to download the core package and the Nova theme. On the client side, we'll be creating a new service called AI Chat Service to communicate with our server-side controller. In this experiment, I've decided to put the chat user interface inside an off-canvas component from Bootstrap, triggered by a button on the sys-tray. We'll implement this by creating an AL component that uses a button in its template with the database target attribute to target the off-canvas component. Let's name this component AI Sidebar Toggler. Next, we'll implement the off-canvas component itself using another AL component called AI Sidebar. We arrange the AI Sidebar component to subscribe the bus service with our AI bot stream notification type and set the notification handler to a function which in turn will call the corresponding function, which will be set dynamically later when the user sends a message. And we also set the AI Sidebar to create the NLUX chat component when it's mounted. To create the NLUX chat component, we create a new method, createAIChat. In this method, we prepare all the necessary data to create the chat component, such as the avatar for the AI and the current user, the input placeholder, conversation history settings, etc. When it comes to handling chat messages, we'll be creating a chat adapter depending on whether the user has chosen streaming chat or regular chat. The adapter will point to the corresponding method in AI Sidebar, which will then call our AI chat service. For streaming chat, NLUX provides an observer object that we can use to create a handler function for the AI bot stream notification type. For regular chat, we simply return the response message to the NLUX chat component. And there you have it, an AI chatbot with a streaming feature using the Semantic Kernel framework and NLUX chat library. Thanks for watching. If you found it helpful, please like and share it, and don't forget to subscribe to my channel so you can stay up to date on all of my experiments and tutorials.